Okay, today we're going to be talking about angles and degree measure. This is in section 5.1 in the pre-calculus book. And what our goals are for this section is to identify angles that are coterminal with a given angle, find the number of degrees in a given number of rotations, and then finally we're going to work on converting decimal degree measures to degrees, minutes, and seconds, and then vice versa. Now the last one's kind of a nice to know. It's actually not something that's going to be tested, but it is kind of something that, it is helpful. It might come up again in some other areas that you're working on. The first two are essential for this chapter. So let's start looking at just some vocabulary that we're talking about. We've been working a little bit, and you should have seen in the past this idea of your quadrants and what quadrant you're in, whether you're in the first quadrant, the second quadrant. So here's our first quadrant, our second quadrant, our third quadrant, and our fourth quadrant right over here. What we're going to be looking at is we're going to be making an angle, and we're going to be like looking at where the start of the angle is and where the end of the angle is. The initial side is the start, and the terminal side is the ending. And we're going to be talking about, okay, if it starts, it's always going to start here. It's always going to start right here. All of our angles are going to start right there, and then they're going to kind of go around in a different degree measure. Kind of like this little thing. Now that's going in a negative degree measure. I think it's keep going around. So that our spinner kind of is going around, and as it goes around the complete circle, it makes a 360 degree rotation. Okay, and that's going in the negative direction. So when it's going around clockwise, it's actually a negative degree direction. All right, clockwise is actually a negative. All right, counterclockwise, didn't quite get right what I wanted to say. Counterclockwise, wise is the direction that we usually go in. That's usually our positive direction, that when we're talking about an angle. So they give us an example here of a 120 degree angle. So let's talk about rotations and where we would be. So you start here, and actually I think I need another. Okay, so we have an angle and it starts here, and we want it as it turns, as it rotates, it gets different measures. So this is about a 30 degree angle, and 40, 45, 60, 70, 80, 90 is right here. So in red, I have a 90 degree angle shown. As it gets higher than 90, 100, 110, it goes on. This would be about 135, and it comes across 160, 170, and this is 180. So that, the red line is actually showing 180 degrees. Right here, it's 190, 200, 210, when it gets down like this, it's a 270 degree angle. I'm going to write 270 here. This was, if you remember, we started at 0, we got to 90 here, and we had 180 here, okay? And as we come around, it's going more, excuse me, it's 280, 290, 300, 310, 320, 340. This comes up to 360. So a complete rotation is 360 degrees. Now if you notice, usually we're going in that direction for our positive. So usually our positive direction is counterclockwise. Now in the first one, it asks us 2 rotations clockwise. Where would we be is basically what it's asking. So clockwise is in this direction. I'm going to get here, I'm going to get this one. So I'm going, here's 1 rotation clockwise, and then a second rotation clockwise. I'd be back where I started from. So I went negative to get 2 rotations clockwise, and I actually went a negative 360 plus another negative 360, which in the end is negative 720 degrees. So that's the way I could show, please go 2 rotations clockwise. So the way that we mathematically say that is we say it by saying go negative 720 degrees. Okay, now let's do it counterclockwise, and that's usually the direction we go for our positive. And let's go 1 1/2. So here's 1 completely around, that was 360, and then a half would be over there at the 180. So here what we did, and I actually jumped here, I went 360, and then I went another 180. And that I got 540 degrees. And I'm sorry, I jumped to this problem. Let me go back to this problem here. All right, so now I'm still going negative there. And 2.5, and you know what? I think I can even do this without, showing it around. I know I'm going to go around 1, 2, and then another half. So again, I'm going to end there. All right? So what I did is I did a negative 360 for a round, and I did another negative 360, and then I went negative 180. If you add up all of those negatives, it actually turns into negative 900 degrees. Now, it might be at this point you're saying, oh, there's got to be an easier way than kind of thinking about all those negatives. Well, there is. 2.5 rotations. Well, a rotation is 360 degrees. That's where we're doing this. We're doing 360 degrees. So, counterclockwise is positive degrees. Clockwise is negative degrees. Can't we just do this? 2.5 times 360. You bet you can do exactly that, and we end up getting 900 positive degrees there. So it's more of getting used to that. That's what we're talking about when we're talking about our degrees. All right, let's look at another example. Coterminal. So we're going to start with this idea of 50 degrees. I'm going to come back here. Excuse me, sorry. I'm going to grab this one, and I'm going to copy it, because I want my other line here. And I'm going to paste it here. All right, thank you. That's what I wanted. I wanted to kind of show this. So this is always my starting line. So my starting line's right here. There we go. Get it right there. Close enough, right? Oh, I have my finger on the round. Okay. So 50 degrees looks about like that. What they're saying is coterminal is there's another angle that has that 50 degrees. Well, one way you could do coterminal, I'm going to do this. I'm going to copy this here. All right. I'm going to paste it. I'm going to change the color. Let's make it that color. Oh, it didn't change it for some reason. Let's see if I can change that color. Here we go. There we go. Change the color. So there we go. There we are. What if instead I said I go all the way around like this and I go around twice? So if I start here and not just go 50 degrees, but go 360 plus 50 degrees. So I went a little bit extra there. Well, that's what this 50 degrees could be here. I'm going to move it around here. I could say my 50 degrees is really 50 plus 360, and that's really a 410 degree angle. That a 410 degree angle is coterminal, ends at the exact same spot as a 50 degree angle. Sorry about that. And then you also could say that, hey, instead of just starting there, I could have gone the negative direction, and I could come around this way. So there's a way I could do it negative. And what you do for that is you say, well, I could have said 50, take away 360. And then in the negative direction, it would be a negative 310, which is in that clockwise direction. So I can go around in that other direction. Let's look at another one. Let's look at what 110 looks like. 110 looks about right there. Okay. Well, if I had to go positive and I had to find another way to get to 110, and another ways to end there, I could go around completely in a circle and then come back to 110. All right, I ended at the exact same spot. So for that, what I did is I took my 110 and I added 360 to it. That's where I got 500 and, how did I get 500? I got the wrong problem here. Sorry, guys. 110 plus 360 would be 470. All right. I also have the option of going in the negative direction, okay, to say, all right, I could start here at 0, 0, and I can come around in the negative direction and go here. In that case, what I would do is go 110 minus 360, and I get a negative 250. Hopefully you kind of see the pattern that we have here. So like for the 215, I could go 215 plus 360, and I get 575. I could go 215 minus 360, and I can get negative 145. So there's a lot of different ways I can get these angles, okay? Let's look at sometime, and here they were only asking me, I guess really weren't asking me a question. So I think at first we might be just saying to you, find another coterminal angle. But what we do eventually is we do get to some specifics, and we say, okay, find one positive and one negative angle that's coterminal. So 50 degrees. I think we even actually already did this back there. Let's do another one. Let's do instead this 217. Okay, 217 we could do. What I need to do is just 217 plus 360 degrees and 217 minus 360 degrees. All right, we can do those. This one's a negative 143 degrees. This one is 577. Coterminal, this means just ends at the same spot that 217 would end at. Okay, so that's what we had for an answer there. Now, if you have a negative angle to begin with, our process really doesn't change. 196 plus 360, and that one equals 164. Or we could go negative 196 and subtract 360. And that gives us negative 556 degrees. Okay? We could keep adding. We could keep going around in circles. Let's go back to this one. Now, I could tell you there's infinite answers here. So I could say here, I think this was when we were at 110. I said, well, I could go completely around once and then stop at 110. I could go around 3 times and stop at 110. So what I did there is I had my 110 and I added 360 3 times. Well, the idea is if it says, give me the answer to all possible positive coterminal angles here, what you do is you just say, well, you can go and you can add whatever number you want. So you can go around you can go around as many rotations as you want, and it doesn't matter. So that's why you show, this is how you show if they ever ask you, show all possible positive coterminal angles. And this is the way you can kind of show that all possible is to just say, oh, we can throw in an n times 360 because you can go around as many times in a circle as you want. So now that's why what we're working up to is this reference angle. So 50-degree reference angle. So we found out, oh, I gotta do this here, sorry. All right, our 50-degree looks like this. Now I still need, I don't know why I didn't have, I gotta go back here. I gotta copy this again, guys. Sorry about this. Copied it, I don't know if I got it copied. Copy. All right, now I got to go back, and I want it here, because I want to show that we have an angle there. There we go. There's my beginning angle. So we have my beginning angle there and my ending angle. So we have my little angle. My reference angle. So reference angle is always an angle that's shown to my x-axis. So you notice like here, I have my x-axis kind of highlighted in blue. You know what, I'm going to make this is really an important axis for us. So I'm even going to make it thicker here for us. I want to show that, okay, it's really important. We almost kind of ignore the y in this case, and we're always saying, how do we draw a triangle where the right angle is made with that x-axis, okay? So for this angle, when it's 50 degrees, well, it's its own reference angle, because I can kind of make this right triangle right here, right back, so I can make the right triangle right back to the x-axis by making this a 50-degree angle. So a 50-degree angle, the reference angle is its own reference angle. It's still 50 degrees. All right, that might not make sense right now. That's okay. 110 is over here. Okay, I'm going to get rid of this. All right, 110 here. All right, let me delete that. Oh, I didn't want that. Sorry, guys. Delete, delete. Okay, so 110 angle here means from here to here is 110 degrees. We want to know the reference angle. In other words, we want to know what would be the angle that's then brought down to the x-axis, this right angle here. So it's like this would be needed to show and to complete the angle. Well, that angle would be right in here, right there. How would we figure out the degrees? Well, all the way across would be 180 degrees. We know that all the way across here is a 180 degree angle. So we want to go a little bit less than that. We want to take away the 110. So we're going to go 180, subtract away 110. Oh, I get it. This is a 70-degree angle right there. That's my reference angle in the second quadrant. So the reference angle here is a 70 degrees. So we're always going to find an angle that's between 0 and 90 degrees. It's never going to be more than acute angle. It's always going to be acute. So that's what we're always looking for, is how can we kind of get that reference to something that's between 0 and 90 degrees.